Hi, I'm Curt Frye. In this movie, I want to take another look at the traveling salesman problem. And the idea is that I want to have the most efficient route possible when I am delivering packages or boxes to different locations where my customers are. What we've done before is only look at situations where we deliver. We are not actually adding any packages or boxes to our truck. So in this movie, I want to show you how to set up a solution where you have to manage the total capacity of your truck and ensure that you don't plan a route where you are supposed to be carrying more boxes than you're actually able to. The sample file that I'm using is called TSP Pickup and Deliver, and you can download it using the link that I provide in the video description below. In this scenario, I have 7 locations that we will be delivering to, and over in the locations table, I have locations 1 through 7, and those are indicated along with our starting point, location 0, on the map that you see here on the right. And that map is generated using the values that are available here. We are always going to start out at location 0, and I have a VLOOKUP to take the value in A31 and find its location in the table here. And of course, we need to map it according to its X and Y coordinates. So this will always be 0, but the cells below that, until we get to the next 0, are linked to the values in the route that we plan using Solver. So I have A32, the location is mapped to F19. In A33, we look at F20 continuing on. And the map of the route appears here. We want to minimize the distance traveled, so I have calculated the distance between every pair of points, and that calculation is based on the Pythagorean theorem. A squared plus b squared equals c squared, and I have rounded up to the next whole number. So there I have all of the distances between 2 pairs of points, and of course any point where you travel to itself will be a distance of 0. So now let's start calculating the distance between the location in a cell above where we do the calculation, in this case 0, and go down to location number 1. And if I look in the distance matrix, I see that the value should be 21. That's for going from 0 to 1. So I will click in cell G19, and the formula will start with an equal sign as always, and we are going to look up based on the values in the distance matrix table. So we use index, which returns a value or reference of the cell at the intersection of a row and column, and that's where these numbers at the top and to the left come in handy. So I have index. The array will be F4 through M11. I'll press F4 to make that reference absolute so it doesn't change, then a comma. And the first location will be in F18, but we need to add 1 because the actual headers here start at 0. So that's row 1, or excuse me, column 1, then column 2. So we need to go from 0 to the first row here, or first column, then a comma, and then we need to give the column number +1 for the destination. So that will be F19, which you can see there. Also +1 because we start at 0 up above, right parentheses and enter, and I get a distance of 21. And you can also see that I already have my AutoSum formula set up that will find the total of all the distances, and the cell G17, or excuse me, G27 is in green. It has a green background color because that will be our objective cell, and that is how I indicate it. And because of the way that I created the formula in G19, I can copy it down until I cover G26, and there is the formula. I accidentally got rid of the formatting in G26, so I will click the autofill options button, fill without formatting, and there is the value. Because we are picking up and delivering boxes from our customers, I need to ensure that we stay below the capacity of 120, which is here in cell B13. I have already indicated here in cell H18 that we have an initial load of 120, and now we need to figure out how many packages this route would have on our truck when we leave a particular destination. And for that, we need to take the previous load and then subtract the number of boxes that we deliver, and then add the number of boxes we pick up. So if we start with 120, deliver 20, that would take us down to 100. But if we pick up 30, that takes us to 130, which is greater than our capacity of 120 and would not be a move that would be allowed within this model. So let's do our calculations. In cell H19, I'll type equal, and this will be the value in the cell above, so that is H18. We're going to subtract the number of packages at the location currently in F19, so that will be VLOOKUP, and the lookup value is in F19, then a comma, and then we're going to look up in this table over here. So going from 0 to 7, that's A18 to C25, then F4 to make it an absolute reference for both parts of the array, then a comma, and the column index will be the number 2, because the location is in the first column and deliver is in the second. So there's my array parentheses, and now we need to add the number of boxes we pick up. So it will be plus, and we'll do a VLOOKUP again. The value will once again be in F19, then a comma. The table array is the same, so I will just copy that from here. Actually, I'll copy the rest there. Click and paste. And instead of looking in column 2, we're going to look in column 3, which is the number of boxes we pick up. So everything looks good. I'll press enter. And we go up to 130, which is correct. However, we will have to create a constraint later that will make sure that the capacity stays below 120, or equal to or less than 120 if possible. So from here, I will copy this formula down until it covers H26, and I will fill without formatting again. So there we have it. And it looks like taking the locations in numerical order, in addition to being very long and out of the way, would not be possible because of our truck's capacity. Now we have the outline we need, so we can create a solver model that will hopefully find a combination or a sequence of locations that we can use to create our delivery pattern. To create the model, I will go to the Data tab and click Solver. And then the objective cell will be the one we have marked here in green, which is G27. I want to minimize it, that is, get the lowest possible value. And we will do that by changing the variable cells, which are our locations and that I have marked in yellow. So I will click the Collapse Dialog button and select F19 through F25. And I will expand the dialog. The solving method is on evolutionary, and that's because that's what I selected the last time I used this workbook. And if I were to click the down arrow, I could select another engine, such as Simplex or GRG Nonlinear, which is probably what you will see. But please do make sure that you change it to evolutionary, which is what we need because of the complexity of this model. Now let's add in our constraints. So I will click Add. And the first thing we need to ensure is that all of the values from F19 through F25 are different. So with the cell references of F19 to F25, I'll click the comparison operator in the middle and click diff, which forces them all to be different. Click add. We need to ensure the same cells, F19 through F25, are less than or equal to 7. That is the maximum value in our location list. Add. Same cells need to be greater than or equal to 1. That's the lowest value. Click add. And finally, the load at any given time must be less than or equal to the capacity in B13. So the cell references will be H19 through H25, and those must be less than or equal to the value in B13. That's it. I'll click OK. And one thing that I have started doing is to close the solver dialog box without changing or erasing anything, and then press Control S to save. The reason I do that is that when you run a solver model, Excel will occasionally crash. So in this case, I definitely want to avoid that. So I have saved my work, and I will click Solver again to open it up. Click Solve and run the model, and I will come back when it has hopefully found a solution. And we're done. We have found a solution, so I'll click OK. And it looks like that because we have the possibility to exceed 120 on numerous occasions, we will start out at number 7. So we go from 0, which is the start, down to number 7, then across to number 4, then over to number 6, continuing on 1, 5, 2, 3, and back to 0. And it appears that we are actually very close to our capacity, because at 2 stations we are fully loaded at 120, and at another we have only 1 available slot at 119. So if we're working with this group of customers, and this pattern is typical, we might want to get a larger capacity truck because we're working very close to our limit, and it's possible we might not be able to find a solution. And this is how you would create a traveling salesman problem model in Excel using Solver with pickup and delivery. I hope you enjoyed this video. If you did, please like it and subscribe to my channel.